A probability model is a list of each possible outcome with its probability. So if we're going to create a probability model for rolling a die, we need to have its outcome, along with its probability. So the probability of rolling a 1 is 1 out of 6. And a 2, and so forth. And of course we know that each number on the die is what we call equally likely. Equally likely means that they have the same probability. Each number 1 through 6 has the same likelihood of being rolled, so they're all equally likely. Now when each probability is, or all the probabilities in a model are equally likely, we call this a uniform probability model. And once we've constructed it, then we can be asked certain questions like, what's the probability of rolling a number less than 3? So the way I write that is x is less than 3. And we can go up and look at our probability model and see that there are only 2 numbers less than 3, the 1 and the 2. So there are 2 possible numbers less than 3 on the die out of a total of 6. So our probability would be 1/3. And remember that 3 is not included in that. They could also ask us, what is the probability of rolling a number greater than 3? Well, again, that would then be these 3 numbers. So that would be 3 and 6, which is a probability of 1/2. And these, just kind of as a review, this is from the last section, these are not complementary events unless they make up the 2 events, make up all of the possibilities. And sometimes we forget that we have excluded 3. So the complementary event to less than 3 would be greater than or equal to. So let me change colors on that. Change it to greater than or equal to in order to make it a complementary event. Then that would include all 4 of these numbers, and we would have 4 out of 6, which is not, I gotta erase both of those then. It would be 2/3. And not that we have to know this, but then those would be complementary events. The point of what we're talking about here is the probability model and what makes it a uniform probability model. So next we're going to do an example of a non-uniform probability model. So let's do a probability model for the outcome of rolling 2 dice and adding the numbers, finding the sum of the numbers. So a sum of 2, obviously there's no sum of 1 because the lowest you can roll on each die is 1 and 1. So there is 1 out of 36. For 3, there would be 2 out of 36. For 4, 3 out of 36. 5, it would be 4 out of 36. 6, there are 5 ways to get that sum out of 36. For 7, there are 6 ways to get that sum. For 8, only 5. A sum of 9, there are 4 ways. A sum of 10, 3 out of 36. 11, there are 2 ways. And 12, there's just a 6 and a 6, so 1 out of 36. Something else to note about all probability models is if you have a complete probability model, the sum of all the probabilities will add up to 1, or in this case 36 out of 36, which is 1. Now this probability model is a non-uniform. Probability model. And it's because all of the outcomes are not equally likely. So that's just what makes it a non-uniform. So it's pretty easy. If all the probabilities are equally likely, it's uniform. And if they're not equally likely, then it's non-uniform. One more thing I want to mention is sometimes you might be asked silly things like, what is the probability of rolling a vowel? They're just checking to see that you understand that that would be 0 out of 36, so it's impossible. Remember that 0 is impossible. Or what's the probability of rolling a 1? Or a sum of 1. Of course we can roll the number 1, but rolling a sum of 1, so maybe I should make it the sum of 1. Again, that would be impossible because we're rolling 2 dice and adding, so that would be impossible. They might ask something else like, what's the probability of rolling a sum 12 or less? Well, you're going to get a sum of 12 or less, so that would be a probability of 1, so you're guaranteed to get a sum of 12 or less. You can see that our most common would be 7. That's where the term lucky number 7 comes from, is that is the most likely when rolling 2 dice and adding the results.